I think we can get started here with this afternoon's roundtable about differential privacy and census data. Welcome, everyone. I'm John Cho, SCAG staff, transportation modeler. I will be helping to introduce the excellent presenter and facilitate a good open discussion and some Q&A toward the end, alongside with my colleague David here. Just so that everyone knows some of the logistics here, this is just a regular Zoom meeting. It's not a Zoom webinar. So you can unmute yourself just by pressing the little button or pressing *9 if you are on the phone, or you can raise your hand on the Zoom device in the participant side here. Jonathan Buttle will be presenting differential privacy and census data, 2020 census demographic and housing characteristics file. He is a research data specialist from the California Department of Finance's Demographic Research Unit, which is designated to represent the state in national programs relating to population statistics and federal and state cooperative program for population projections and estimates, and the Census Data Center program. It's great to welcome Jonathan here. There has been a long involvement with DOF at the last several demography workshops, and they've always been a great resource here to bring us their latest research, population estimates, projection, and things like that. So Jonathan specializes in designing and programming custom data visualization for the Demographic Research Unit website, retrieval, analysis, and distribution of US Census Bureau products and data set, and assisting clients both inside of and outside of the DOF with questions about American Community Survey, current population survey data sets, and producing custom data tabulations. His research interests include data science with an emphasis on visualization. And Jonathan has an MA in economics from the California State University, Sacramento. He was a Jesse Marvin Unruh Assembly Fellow, and prior to working at the Department of Finance, served as a budget analyst for the California Department of Consumer Affairs and Contractors State License Board. So thanks everyone for coming here, and let's give warm welcome to Jonathan, and I will hand it over.
Thank you, John, for that introduction. So let's go ahead and get started. Let me go ahead and share my screen. Okay. Again, my name is Jonathan Buttle. I'm with the California Department of Finance in the Demographic Research Unit. And what I'm going to be discussing for the next 30 to 40 minutes is the Census Bureau's implementation of differential privacy and census data, specifically focusing on the 2020 Census Demographics and Housing Characteristics file. Okay, what we are planning to cover in this and discuss, hopefully, is why differential privacy. What is differential privacy, and why did the Census Bureau decide to adopt this as its preferred method of privacy protection for its data? The components, what makes it up, the differential privacy mechanism, how that is applied to the demographics and housing file. We'll take a look at some of the recently released demonstration products, and finally, we'll talk about submitting feedback to the Census Bureau. Okay, so why differential privacy? The Census Bureau takes protecting the privacy of its survey recipients very seriously. There's a couple of statutes on the books, Title 13 and Title 5 specifically, that the Census Bureau reads as fairly strict in their mission to protect data. And so as a result, the Census Bureau has over the years employed a number of data protection mechanisms designed to protect specific identities and not allow for specific persons to be identified with data releases. Up until the 2020 census, since about 1990, The Census Bureau has been using data swapping through a variety of mechanisms, which it has not disclosed. But for the 2020 census, the Census Bureau has adopted differential privacy as its flagship means for protecting the identity of people that have responded to its various surveys with the 2020 census. The reason that the Census Bureau did that is prior to the 2020 census, it conducted a series of reconstruction attacks on the 2010 census data tables to try to find out how easy it would be or what the possibilities were for somebody with a powerful enough computer and enough data knowledge to be able to actually reconstruct identities from the various tables published as a result of the 2010 census. What they found alarmed them. And so as a result, they went ahead and started looking at differential privacy, which had been developed in the prior decades by computer scientists as a way of attempting to protect identities and to quantify that protection. Okay, so what is differential privacy? Differential privacy is a mathematical technique, and it allows for the formal quantification of risk of a data breach or a data disclosure. And really, it boils down to a property of algorithms that are used to answer queries from a data set. Because of this, it allows for a way of mathematically quantifying the risk. And it provides formal bounds as to how many queries can be made before the probability of learning specific information moves beyond acceptable levels. So simply, differential privacy can be thought of as imagining two databases, one that contains your information and one that doesn't. So what it does is that it stipulates what the probability would be that the result generated by a query on either one of those databases will be nearly identical. In other words, an observer cannot determine what is a true database by simply looking at the output. Okay, the components of differential privacy. The main component will be the privacy loss budget. It's noted, it's represented by epsilon, and epsilon can go anywhere from 0 to infinity. If epsilon is equal to 0, the resulting data release would be random and essentially useless, but it would provide perfect privacy for those people participating in the survey. On the other hand, if epsilon is extremely large, the resulting data would allow for the full identification of the participants, perfect accuracy, but absolutely no privacy. So what they're really shooting for is to pick a value between 0 and a very large number to basically minimize that, while at the same time having the data to actually be useful. Okay. Epsilon is also known as a privacy budget. The privacy budget basically tells you how many queries you can release and what kind of queries you can release. If you're only doing a single query on a database, then it's possible that the epsilon would be using up the entirety of the budget. However, if you perform a series of queries on a data set, and it requires the allocation of the budget over all of those queries. So keep in mind then that there are two methods of allocating the privacy budget, sequential and parallel. Parallel composition is where data is released from non-intersecting records. So for instance, if I wanted to know the population of Sacramento County, and I also release the population for Los Angeles County, there is absolutely no interaction between survey participants for those two particular counties. So as a result, the epsilon, the global epsilon for those two queries would simply be the larger of the two epsilons. Likewise, sequential composition is where you release a number of data sets that intersect that contain the same participants. So an example of that might be the population of Sacramento County and the population of Rosemont, which is a CDP located within Sacramento County. Obviously, there's going to be intersection between those two releases. And so the global epsilon for just those two releases would be the sum of the epsilons for each of the individual releases. Okay, this next slide kind of illustrates the trade-off between privacy loss and accuracy. You can see that for a very low epsilon, you're going to have basically no accuracy whatsoever in the data release, but you're going to have very high privacy. On the other hand, the privacy loss as epsilon grows, goes down, whereas the accuracy, whereas the accuracy increases and the privacy actually goes down. And you can see that it's not a straight line, it's actually a curved line. Okay, Census Bureau has implemented differential privacy by employing what's called top-down methodology. What it does is creates a series of histograms of various tables it plans to release. These can include total population, voting age, race, ethnicity, etc. It assigns them to the various geographies that are found within nation, state, county, place, etc. It then applies noise to each of these attributes by adding the results from a random number generator. In this case, for the DHC, it's going to be discrete Gaussian number generator to the attribute counts. Finally, it takes those results and then applies a series of post-processing algorithms to ensure that the data is consistent. So in other words, what it does is it ensures that the data adds up correctly. So all the counties in Sacramento will correctly add up to the state population for California, and also preserves what are called the invariants. And for the 2020 census, to date, the invariants are the total population at the state level and total housing unit and global group quarters counts down to the block level. Okay. The mechanism works by injecting noise into the data. The amount of that noise is determined by three parameters: epsilon, which we already discussed, sensitivity, which is the amount that one or more individuals or records can influence the output of the mechanism, and finally, delta. And delta is a parameter that's used in the discrete Gaussian noise generating mechanism. Basically, what it boils down to is it is the probability of a catastrophic data breach. We'll take a little more detailed look at that in a minute. To date, the Census Bureau has used two distributions. They've used a distribution from the Laplacian distribution, which returns pure differential privacy. But currently, they have switched over to using the discrete Gaussian distribution, basically the normal distribution, and that returns nearly pure differential privacy. By nearly pure, it differs by the value of delta. So 1 minus delta is the probability of actually having pure differential privacy. Okay, one thing to keep in mind is that once differential privacy is applied to a data set, you can go ahead and do any sort of processing you want to that data set as long as you don't bring in anything new to that data set. So you can't go back and look at the original data set and apply any of the characteristics from the original data set. But as long as you stay within the privacy protected data set, applying any sort of post processing on that data set pretty much ensures that the privacy is maintained. So you can do things like ensuring that counts less than 0 are either made 0 or some number above 0, depending on what kind of consistency you want to enforce. And you can also assure that the counts for lower geographies sum to counts of higher geographies. Okay. The current implementation includes a couple of changes to the geographical hierarchy. One of these is a new geographical category, the population estimates primitive geographies. What that is it allows the Census Bureau's program, population estimates program, to be able to derive the tables they need from privacy protected data in order to ensure that in their construction of estimates and whatnot, that data is also privately protected. And as a result, because those geographies don't always align with census tracts, the hierarchy also incorporates two new categories, tract subsets and tract subset groups. So tract subsets are the intersection of the primitive geographies with tabulation tracts, and subset groups are simply the union of multiple tract subsets within the same estimates geography. Keep in mind that these geographies really have no impact on the data that's going to be released or how it's tabulated within the DHC itself. Okay. The second release of the DHC DAS demonstration incorporates changes from previous versions. There were a couple of mechanism changes to note. The global epsilon for unit tables was increased from 3.87 to 6.14. And there's been a revised distribution of the privacy loss budgets to favor national and state tables at the expense of block and block group tables. This pretty much leaves the county and tract tables relatively unchanged. There were also some table changes with the second release of demonstration data. The Census Bureau is currently proposing a total of 249 tables for inclusion in the DHC release next year. They've also looked to reduce the geography to census tract level from state or county for 16 of those tables and for 16 iterated tables. And finally, they've added a sex by single year of age table repeated by race and ethnicity at the tract level. All these changes came about through comments that were submitted to the Census Bureau from the first DHC demonstration data set. Okay, so let's talk a little bit about the upcoming release schedule. So far, the 2020 census apportionment file and redistricting files have been released. The planned future releases are the DHC and demographic profile in May of 2023, May of next year, and then the detailed demographic and housing characteristics A table, which is looking to be released in August of 2023. That particular table is going to contain total population and sex by age for detailed race and ethnicity. There's also looking to be a detailed DHCB table, and that is household and tenure, also by detailed race and ethnicity. That particular table, there has been no specific release date announced as of yet. Finally, the Census Bureau is looking to produce a supplemental DHC, and this is people in households. So this is actually a tabulation that will look at average household size and things that actually require a combination of the persons and the unit tables. The Census Bureau is still working out how that's going to be implemented, and so there's no release date announced for that yet. Okay. Really quickly, this is the product development schedule. We are right now in demonstration data round 2. Comment period closes on September 26th. So, and then the Census Bureau will parse the comments as well as take a look at the results. And then they're looking sometime in late fall or winter, probably December. There's going to be decision by the Census Bureau as to what the final budgets are going to be and what the tables are going to be. And so final processing starts after that point, sometime in the winter of this year, and that will go into the winter and spring of 2023, and hopefully with the May 2023 data release. Okay. The current release mechanism incorporates the following parameter distributions. For the persons table, the global epsilon is 21.97. That implies a row of 3.65, and that is actually used in the mechanism to generate the noise. The global delta is 10 to the minus 10th. And that is the same as the release for the 2020 PL94 files. As I had mentioned earlier in the presentation, the delta gives you the probability of a catastrophic data breach. And then 1 minus delta gives you the probability of a pure differential privacy release. So in this case, based on that, the probability of having a pure differential privacy is 99.999%. By contrast, the unit housing tables are looking at a higher global epsilon of 29.92, which implies a row of 6.14, twice as much as the row for the person tables with the same delta. Keep in mind that comparison is that the final production epsilon for the PL94 for the persons table was 17.14. So you can see that the epsilon for the persons table here is fairly large, and also the epsilon for the units was 2 point, I don't have the number in front of me. So the epsilon for the unit tables is much larger than what was released in PL 94. Okay. So taking a look at how the budget is going to be distributed for persons, you can see that the emphasis is going to be at the state and county. And also the track subset is going to get a fairly large chunk of that. The block units are going to get the smallest chunk of that. And of course, the Census Bureau has emphasized that for accuracy's sake, queries at the block level are probably not going to be the best way to go. However, of course, it's entirely possible that there are going to be quite a few people that actually need block level data. The problem is that there's going to be accuracy issues as a result. Likewise, for the units, US and state are going to be at the top of the budget. Track subset is going to be next, and at the low end is going to be, again, the block level. Okay, this next table gives you an idea of the percentage allocation by geographic level and query for the persons tables. The allocation is primarily by geography. You notice that for all the queries that they have planned, it's going to be the same distribution. And what we're seeing is that the state is going to be getting a fairly large share along with the track subset, and the block level and US are actually going to be getting the smallest share of that particular budget. Okay. Likewise, for the units, this is the allocation by geographic level. This, you should notice, is looks a lot different than the persons table in that it's not consistent across queries. It's not even consistent across geographic levels, in that what you really see is that there's a number of 0 percentages in this table. And what that basically means is that there's not going to be any queries run at those geographies where there are actually zeros. And there are quite a few in this table. The next tables will kind of give you a little better idea of that. Okay, so this is the sigma squared or variance distributions for the persons tables by geographic level. Remember that the distribution being used for this particular run is the discrete Gaussian, which is a normal distribution. You can see that by far the block level queries are going to have the largest variance distribution, with the smallest going to the state, the county, pretty much the inside distributions, and the US having a relatively larger share. Likewise, the per query variance allocation by geographic level for the units tables, you see there's a whole lot of NAs in that particular table. Again, the implication being that there are not going to be queries produced at various levels of geographies for the unit level queries. And really, this is kind of borne out when you take a look at some of the documentation that the Census Bureau has released when it comes to what tables are going to be planned for release, at least at this point. Okay, so just to kind of give everyone here an idea of what these numbers mean, this is a distribution graph for the variances for the persons tables. And again, what you see, the noise distribution is going to vary between plus or minus 150, and really, when you think about that, you're looking at block level counts, especially block level counts that have multiple dimension tables that are in the queries. It's very easy. You're going to see a whole lot of negative numbers in those particular queries. Interestingly enough, the United States tables are looking at noise levels between plus or minus 50. And then the interior tables, county, the primitives, the track levels, and the optimized block groups are going to have the smallest actual distribution of noise, somewhere anywhere between 25 to 30 plus or minus. Okay. This particular slide shows the distributions for unit allocations. And you can see again, block level is going to have the widest block noise allocation, anywhere between somewhere 75 plus or minus 75 plus or minus 80 for a couple of the queries. And then taking a look at some of the outsider queries where there's only a few geographies represented, you're looking at a much smaller noise distribution, anywhere between plus or minus 40 and plus or minus 20. Okay. So now let's take a look at some of the results from the second round of DHC demonstration data release. I'm going to look at three place geographies. The first is a relatively small CDP, Acampo. They only have a population of 341. And you can definitely see there is, the shape is not necessarily preserved in this particular graph. Keep in mind, though, compared to graphs for this particular geography in previous releases, this is actually a lot more accurate. I also included the mean absolute error across this based on the age groups that are represented in the population pyramid. You note that the age group is 4.8. Keep in mind that what you're going to need to compare that to is the average population, and we'll go ahead and discuss that in a few minutes. Okay. Likewise, for Susanville City, it has a prison, so you can see it's skewed in male population compared with female population. It has a 2010 population of 17,947. And you can see how two things to notice about this. It looks a lot more accurate than the previous slide that we looked at, and the mean absolute error is also higher than the one that we previously looked at. Okay, the third is Sacramento City. It has a population of 466,000 as of the 2010 census. Relatively symmetrical distribution, and you can see there's not a lot of differences based on the differential privacy release compared with the actual data release. It also has a mean absolute error of 20.2. Keep in mind, when you're looking at larger populations, you're going to be looking at larger differences. From differential privacy release data set and with the actual data set released for the 2010 census. And this is pretty much normal. What you have to really kind of keep in mind is that you need to actually compare this with the averages. And what you'll find is that comparing the averages for Susanville, you're talking about the error percentage compared to the average population is actually around 2%. Whereas for Sacramento County, that percentage is going to be much, much, much lower, somewhere 0.007. Okay. So the Census Bureau has released a series of metrics with each release of differential privacy data sets, demonstration data sets. The purpose is to allow users and stakeholders to kind of take a look at the accuracy or lack thereof of accuracy, and to give them the ability to be able to kind of understand how this works. The metrics include measurements of accuracy, bias, and outliers. And for users needing to explore tabulations that are not included in metric tables, the Census Bureau has also released a data set for pretty much all geographies across the United States. It's a rather large data set, not easy to work with. Okay, so the measures of accuracy, let's talk about this for a little bit. And it's measured by comparing post-disclosure protected tabulations to the original available tabulations from the 2010 census. These measures include mean absolute error, mean numeric error, root mean squared error, mean absolute percentage error, and coefficient of variance. Likewise, for bias, it's similar to accuracy, but it measures the direction of change. And this is important because it allows you to see how differential privacy can distort the counts from larger blocks of individuals to smaller blocks of individuals. These bias measures include mean numeric error and mean percentage error. So let's go ahead and take a look at some of these. Okay, this table is an accuracy table derived from the two releases for the DHC, the first on March 16th and the second on August 25th. And what you really see here for this particular table and its total population for county by size categories is that there really is no difference. There really was no particular change across this. So for this particular unit for counties, for this particular measure, there really was no change in accuracy. Okay, so now let's take a look at accuracy bias and outliers. This is a different table. This is a household size for counties by size of the household. And what you see here is a couple of things. The first thing that you notice is that actually the accuracy of the data as put forth by the measurements included on here didn't increase, it actually decreased. You can see that the count of geographies with the absolute percentage difference exceeds 5% actually went up for all across all categories. So actually the improvements that the Census Bureau made to this particular mechanism for this table did not increase accuracy. Likewise, take a look at the mean percentage error. And what you see is that for 1, 2, and 3 person households, it's negative, whereas for 4 through 7 or more person households, it's actually positive. And what that tells you is that there was a number of population that was moved from 1, 2, and 3 person households and was transferred to 4, 5, 6, and 7 or more person households. This is one of the issues with differential privacy. This comes about through the post-processing mechanism that Census Bureau uses to ensure consistency in the data products. Unfortunately, the numbers have to be shifted in order to assure that these that consistency is maintained. So what the mechanism does is it takes population from larger areas and moves those into smaller areas. And so we've seen this distortion not only with this data set, but in prior data sets, and it especially has shown up in rural versus urban data sets and measurements. Okay. So this is another table which compares measures of accuracy for the March 16th release compared with the August 25th release. And for this particular table, which is all counties, 1 through 17 years, what you're actually seeing is that the accuracy did increase across from March 16th to the August 25th data set. You pretty much can see this in all measures. It's not a dramatic increase. You're not seeing dramatic changes, except maybe for the 15 through 17-year-old populations, but you are seeing a marginal increase in accuracy pretty much straight across the board for all of these particular categories. Keep in mind the Census Bureau is still working on improving accuracy for a number of different geographies, one of which is school districts. So if school districts or what the like is something that you're interested in, you definitely want to take a look at the metrics tables that Census Bureau has put out and kind of take a look at what those numbers look like and how that might influence how you would use the data. Okay. Census Bureau has called for public feedback, as they have done again in the past. The feedback will be accepted through Monday, September 26th, and they're looking for it to take the following forms. They want you to identify the table or tables in question, analyze the difference between the demonstration data and the census data, published census data, note whether those differences along with the metrics are acceptable or not. And if they are not acceptable, providing them with what difference or metric value would actually be acceptable. And finally, identifying how these differences impact your use of the data. Moving on, they provided 2 examples of what they consider to be useful feedback. The first is comparing measures of accuracy or bias across the 2 demonstration products for multiple characteristics and comparing measures of accuracy or bias with the average or count of the characteristic in geography. Comparing the measures across 2 demonstration data products has the advantage of that you can use the measures provided in the metrics tables, assuming that the table and geography that you want is represented. Whereas comparing a relevant measure with the geographic counts also has the advantage of being able to use the metrics tables. However, comparing measures with population averages for geography might require custom calculations to derive that average. The reason for that is that the metrics that document that Census Bureau has put out, the spreadsheet, does not include the averages. They include the geographical counts for the geographies, county, places, school districts, whatnot, but they don't actually provide any of the averages, which requires you to go ahead and calculate those. Okay, so let's take a look at a couple of possible examples or examples of possible feedback that you might want to produce. Going back to our 0 to 17 table for counties, a comparison of the mean absolute error between the March 16th and the August 25th data set, again, shows that an increase in the accuracy. Likewise, for the mean absolute percentage error also shows an increase in a number of the different categories, especially 15 to 17-year-olds. Finally, the count of the counties where the numeric difference exceeds 5%, again, shows quite an increase for 15 to 17-year-olds, but really doesn't show the same magnitude of increase or actually some decrease in accuracy for the remainder of the categories. So this might be one way to do the analysis. Another way is comparing the measure of accuracy or bias with the average or count of the characteristic in geography. For this table, I used the population counts and average of those counts from the actual published numbers. And so for each of the categories, it gives you the population and then the average population, which is an average by county for each of the age categories 0 to 17. And it allows you to do a comparison of the mean absolute error as well as the mean absolute percentage error. So that also might be another way to analyze this data. Okay. That pretty much is the end of my presentation. At the end of the slides, I provided a number of resource links that you can use if you're interested in looking at differential privacy, how the Census Bureau has implemented it, how they might implement it into the future, and also some resources for outside analysis for the data products. One of which is a link to the NHGIS data sets. They went through and actually parsed the data sets for the August 26th and provided a series of very handy, much smaller data sets by geography. The only data set they really don't include is state level block data. We will shortly be putting that block level data up from both the 2010 census and the August 26th distribution data set up on our website as a series of zipped files for all California blocks as well as other California geographies. Okay, that's it for my presentation.
Thanks, Jonathan, for the great presentation. I appreciate it. We've got about 20 minutes or so for question and discussion.
I'm going to go ahead and stop sharing my screen.
All right. Don't see any questions in the chat yet. If anyone has any question, please unmute yourself or put your question in the chat or use raise your hand function. I have one question, Jonathan. How is differential privacy related to margin of error in HS data?
So one of the things that the Census Bureau that had been talked about the Census Bureau was actually providing a margin of error for the data that was released to kind of give data users some idea of what the brackets are for that particular data. It was talked about with the PL94 data. Part of the problem with that is that if the Census Bureau was actually using differential privacy without really any sort of post-processing, it would be relatively simple to do that, simply because of the fact that you would be looking at numbers pulled straight from the distributions, and you can easily go back knowing the distribution and calculating a confidence interval or a margin of error depending on what your confidence level is for that particular data. However, post-processing complicates that because of the fact that you might have, say, a statistic that after differential privacy is applied to that statistic, it's now a negative number, whereas post-processing doesn't allow any negative estimates. It has to be either 0 or greater than 0. And also because of the relative movement of data estimates from geographies from say rural to urban, or say from particular data categories, say from 1 household or 2 household all the way to say 7+ household, it really complicates it. So unfortunately, it's not all that particularly easy for them to do. Census had also talked about releasing the raw privacy protected estimates prior to post-processing, but as of yet, there hasn't been any movement on that.
All right. So can we still use like block group level data with that differential privacy and high margin of error? What do you recommend to the city planners?
That in itself is an issue, and Census Bureau themselves don't recommend that you use anything below the track level, simply because of the noise distributions that are applied to the data as part of the differential privacy process. You're absolutely right. It's not just for city planners. It's also for people looking to construct estimates of housing units at the block level. So this does definitely impact a lot of people who need to use this data. Your best bet, honestly, is to provide commentary to the Census Bureau prior to September 26th. Specific use cases would definitely be the way to go if you can provide something that shows that you have to use this particular data, and take a look at the metrics tables that the Census Bureau has put out and see if you can find something in there. But yes, you would definitely be best bet to present a case to the Census Bureau and explain to them why you need to use the data at the block group or the block level.
That's great. Are there any questions from the audience? I think for metropolitan planning organizations like SCAG, we use TAG level data set that includes population, household, and employment. And TAG is roughly equivalent to census block group. But we have like local input, local data exchange. So we use different input data to estimate population, not just ACS data set. So we communicate with local like city planners if the numbers or estimates does make sense. So we have that like safety measures as well. But I think it looks like MPO would have more role to provide like smaller geography level demographic data sets. All right, I see. All right, I think, Jonathan, you can see the chat question from Beth as well.
Now, I think Beth raises an excellent point. There has been discussion among other users as to either how they can go in and try to extract the data to get what they need on a more accurate basis, or looking at other data sets completely, and as a way of either comparing it with the Census Bureau's release data set, or going to other data sets entirely. What those data sets are, of course, I don't know off the top of my head. I know that there are a number of them out there, but yeah, it's with differential privacy, and especially since Census Bureau is very open about how they are applying the algorithm and the issues that are going to result from that, which is something they were never able to do when they used straight swapping, definitely has opened a Pandora's box in a lot of ways for this data, and caused a lot of people to question it. And yet, interestingly enough, there have been people who have tried to compare swapping with differential privacy. There's one paper in particular that I found interesting. It was presented at National Science Foundation Conference. I have the link up in the notes for the presentation. And the paper, basically, the authors of the paper attempted to use a simplified version of differential privacy and compare it with, I want to say 2 to 3 different swapping algorithms that were derived from a number of papers that the Census Bureau also pulled their algorithms from. Of course, they're not exactly what the Census Bureau used, but they did give the authors a chance to be able to compare the results. And interestingly, what they found on a completely synthetic data set, so they actually did have the original data, and they were able to compare accuracy as to differential privacy and swapping. And at least for their algorithms that they use, they found that for race ethnicity estimates, especially, they actually found the DP algorithm to be superior in terms of accuracy to the swapping mechanism. Of course, there were some limitations to that study in that they didn't use the full DP engine. They used a simplified version of it, and they weren't able to use the exact algorithms that the Census Bureau used, but still, it was a really interesting look at and possibility as a way of really kind of getting down to how the returned estimates actually are distorted from the original data using both regimes.
All right. Are there any further questions or just comments or any feedback? Looks like none. Okay. All right. I want to thank everyone for participating, and Jonathan for great presentations and informative discussion as well. Don't forget the part 2 of the demography workshop next Wednesday. I look forward to seeing you all there. Thank you all.